Hello, this is Calvin Cox. It's Wednesday, October 17, 2012. It's 8:39 p.m. The talk I want to give is probably nobody's going to believe me for anything on this, but theoretically what I'm going to tell you is completely true. And there's no way anybody's going to ever be able to prove it until we send a probe to the sun or around the sun that can collect a huge volume of what would be considered the sun's atmosphere and actually measures and proves what I'm getting ready to say. Now you better hold on to your seats because this is a good one. And it's really amazing. Okay, there's so many things about the sun, people, that we don't really understand. With the newer telescopes and satellites and things that have managed to get fairly close to the sun, and Earth-based telescopes and space-based telescopes have shown pictures and have gotten down real close, and you can start seeing a lot finer detail when they take the pictures and they put filters and they filter out a whole bunch of other stuff that the older pictures you couldn't really see what was going on. And mankind is learning a lot about the sun, but there's a lot of things that are still very theoretical, and I've thought about it a long time. And what I'm going to claim this evening, I fully believe. The sun starts by hydrogen, gravity expanding through a huge wide body, and eventually hydrogen pulls together and other space debris, and they come together faster and faster, and they just down to a small, and it sparks. There's so much heat and pressure it sparks the beginning of a sun. Now through the process of fusion, the hydrogen through fusion, when two hydrogens join, they become helium, and that releases energy. And so that's how the sun creates its own energy. But the first 8 elements are, if I get them right, hydrogen, helium, lithium, beryllium, boron, carbon is the 6th, nitrogen is the 7th, and oxygen is 8th. And so there's a whole lot of those elements, the first ones being created. But my point being is that, for instance, my claim is that there's actually a lot of water, W-A-T-E-R, on the sun, in the sun, on the sun, and around the sun. Okay? But it's water in the form of super high temperature steam. Okay, the surface of the sun, the actual core of the sun, is supposed to be like 25 million degrees, and it's like a plasma. The surface of the sun is supposed to be about 9,000 degrees, and I think it can vary by perhaps a few thousand degrees. I think on the sunspots, that's another talk, other stuff about sunspots. But my point being that when hydrogens join, become helium, and then 2 heliums can join and become beryllium, and then if 2 berylliums were to fuse together, they would become oxygen. Okay, so a lot of oxygen is produced in the star, and there's also other hydrogen nearby. Now, here on Earth, if you take a container of hydrogen and a container of helium and you mix them together, you need to first be careful they don't explode. But it's possible you might need a spark, like a lighter or something like that, to get them to interact. But a match or a lighter, that flame is about 400 degrees. Well, on the sun, 9,000 degrees. Just everywhere it's at least a minimum of 9,000 degrees. Okay, So you don't need a lighter. The oxygen that's produced in the sun and the hydrogen that's already there, they're going to just go ahead and create water. So you have all the hydrogen you need and all the oxygen you need for an automatic, and all the heat you need to start that reaction for them to, come together, give off energy, and create water. So then now you have water. Immediately it's going to become superheated steam. It's going to be steam that's going to be at 9,000 degrees. Somebody might say, well, you can't have steam at 9,000 degrees. It would all come apart. Well, no, not really. A coal-fired power plant here on planet Earth produces steam, I believe I've read, about 900 degrees Fahrenheit. And so if you think about that, 900 degrees, 9,000 degrees, that's quite a bit of a difference between the two. But it's just a bit hotter steam. It's superheated steam. And for steam to break back apart into hydrogen and oxygen again, for the bond to be broken, you would probably need to be up, I don't know, in a plasma, maybe a million degrees, a couple of million degrees, maybe more than that. I don't really know. But I know, I'm very sure it would be much more, way higher than 9,000 degrees to get the hydrogen and oxygen to decouple. So my point is, everything's there in the sun. There's hydrogen, there's huge amounts of oxygen, they're in close proximity to each other, so naturally they're going to come together and join and create water, which is going to become immediately superheated steam at 9,000 degrees or a little bit higher, depending on where it is from the center to the outside. Okay, and there's probably a huge amount. So that steam eventually would come to the surface and also travel way out, and there would be some atmosphere of water vapor around the sun, and the sun's gravity would hold it. Okay, so I don't know, that's still probably pretty hard for some people to believe, but enough said.